So in this problem, we are asked to graph y equals negative x squared plus 5x minus 6 using properties. So what does that mean, using properties? Well, it means we have our standard form here for a quadratic. Y equals ax squared plus bx plus c. And that tells us certain properties. First off, what's our leading coefficient here? What is a? Well, we know that a equals -1. Since -1 is less than 0, that means that we know the parabola opens down. It's going to have a vertex that is a maximum. Now, what else does this tell us? So first off, we look at the leading coefficient. Now we're going to look at what's the axis of symmetry. So remember, how do we find the axis of symmetry? The axis of symmetry we know is a property of this form, y equals ax squared plus bx plus c. And it's x equals -b over 2a. Well, we already know that our a is -1, but what's b? b is 5. So we end up with x equals -b over 2a, which equals -5 over 2 times -1, which equals 5 halves. Now, what else does that tell us? Well, that tells us that we have not only an axis of symmetry at 5 halves, and we'll go ahead and we'll draw that in on our graph. So 5 halves is our axis of symmetry. And we don't technically need to include the axis of symmetry for the graph of a quadratic, but it does help and it doesn't hurt. So we should go ahead and graph that. What else does this tell us? Well, it tells us that that is the x-coordinate of the vertex, and how we find the y-coordinate of the vertex is we substitute that for x. So y equals -5 halves squared plus 5 times 5 halves minus 6. And then we simplify this. -5 halves squared is going to equal -25 plus 25 halves minus 6. And if we put that all over a common denominator, we get -25 plus 50 minus 24 all over 4, which equals 1/4. So our vertex is at 5 halves, 1/4. We're right about here. Now, what else can we do to find the graph, or to graph the curve for y equals -x squared plus 5x minus 6? We know that it opens down because the leading coefficient is negative. We found the axis of symmetry, which means we find a point on one side at a specific y value. That far on the other side of the axis of symmetry is also going to be a point. And we found the vertex. What else we can find is we can find the intercepts, if there are any. And since it opens down, we know that there are going to be intercepts because the vertex is above the x-axis. But first off, let's try to find the y-intercept. So the y-intercept is where x equals 0. If we substitute x equals 0 into y equals -x squared plus 5x minus 6, we get 0 plus 0 minus 6. So the y-intercept is just 0, -6. We should always include some indication of a scale, either the actual points or put a 1 right there to signify that each unit square represents 1 unit. But now if we have a point at 0, -6, remember what I said earlier about the other point that it would have? Well, that's 2.5 at y equals -6 from the axis of symmetry. So we can go 2.5 in the other direction. And we know there's going to be a point there as well. That would end up being 5, -6. So we also know that there's a point at 5, -6 based on symmetry, a property of the quadratic. We could stop there, but let's go ahead and find the x-intercepts. Remember, that's when y equals 0. So we have -x² plus 5x minus 6 equals 0. Let's go ahead and get rid of that negative leading coefficient. Divide both sides by -1, and we get x² minus 5x plus 6 equals 0. And now we're wanting to know, are there any two numbers that multiply to 6 that add to -5? So they're both going to be negative, and it would be 2 and 3. X minus 2 times x minus 3 equals 0. If we multiply back through, that gives us x² minus 3x minus 2x, which is minus 5x, and then -2 times -3 is plus 6. So that means x equals 2 or x equals 3. So that means our x-intercepts are 2, 0 and 3, 0. Now we can go ahead and put all of this together. If we wanted to check our graph, we could put some inputs in for a couple more x values and verify that they do end up on the curve that we have graphed. So just to recap, graphing a quadratic using properties, we started off by looking at the leading coefficient. If it's negative, that means that the parabola, the quadratic, is opening down. If it's positive, that means it's opening up. In this case, it was negative. We found the axis of symmetry using the formula x equals -b over 2a when we have the form y equals ax² plus bx plus c, the standard form for a quadratic. That's also the x coordinate of the vertex, so we substituted that for x, solved for y to get the y coordinate of the vertex, and then we substituted x equals 0 to find the y-intercept, and y equals 0 and simplified and solved to get the x-intercepts, and then we put it all together to graph our parabola that represents the quadratic equation that we were given.